Hello class, I'm Dr. Wilkes and I'm your instructor for Math 150. I thought we'd be meeting on September the 9th on Wednesday in our first class, and I just give you PowerPoints for instruction on our lessons as long as we're virtual. But this lesson had so many drawings in it, I just thought I'm just going to make a video. You can watch this and I'll draw up here and sort of explain. So I hope this works until we can get together in person and straighten some of these things out that you may have questions about. All right, the first thing we're going to talk about is some things that I noticed in your quizzes that some of you were doing that you might have had problems on. These symbols right here. All right, this symbol, this kind of round looking E stands, for, is an element of. And it's just a member of, there are 4 elements in this set. Now notice they're separated by commas. If that's how I know there's 1, 2, 3, 4. So Dad is an element, Mom is an element, Billy's an element, and Sally's an element. Notice Joey is not. All right, so that's what this means. Is not. It's an element with a stripe through it. So, for example, Joey is not an element of this set. The next symbol, the C with the line under it, stands for subset. And a subset is not just one member, but it's a set that the members come from the universal set or a particular set. So a subset of this could be, I could say, okay, all the people that went to school today, and that set could be Billy and Sally. Well, those two came from this set, so Billy and Sally, that's a subset. It's a smaller part of it. Or how many ate fried chicken last night? And it could be all of them, Dad, Mom, Billy, Sally. So all 4 can be a subset. We could say how many of the people go to college right now, and it could be none of them. And so then that would be what's called the empty set. And we have 2 symbols for that, either the 0 with a slash through it or empty braces. Either one of those, same thing, they're empty sets. So a subset, the empty set's a subset of all of them. Okay, and this is a proper subset, and it just means all the subsets except the one that has all of them in it. It's not proper to get them all. Okay, really, it's okay. But I remember it because of this. This one has the line under it. It reminds me of a less than or equal to, and this one does not. That's more like a less than. So it's less than everybody, or less than or equal to all of them. That's kind of just, it's not really what it says. All right, now I listed over here the subsets of this family. Dad, Mom, Billy, and Sally. And I do it sort of methodically. I have a method. I say, okay, I'm going to do all the subsets that just have 1 member in it. So right here I thought, well, Dad's a subset. Mom's 1, Billy's 1, and Sally's 1. They're a subset. They're a small part of this set. Then I say, well, maybe I can list all the 2-member subsets. So I use Dad with Mom, Dad with Billy, and Dad with Sally. Then I don't want to put Mom and Dad because I've already got that. Mom with Billy and Mom with Sally. Then I do Billy with Sally, and Sally's already combined with everybody. So now I go to the 3-member subsets. Suppose I have a ticket to a ball game and I only have 3 tickets, and they can go to any 3 of these. Well, we could leave Sally at home. We could leave Billy at home. We could leave Mom at home or Dad. Those are our 3-member subsets. And then suppose everybody gets to go. That's our 4-member subset. Or suppose everybody, unfortunately, is sick and nobody gets to go. And that's our empty set. Now, if we count those, there are 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I knew there were going to be 16 because it's always 2 raised to the power of how many elements you have. 2 to the 4th is 16. 2 times 2 times 2 times 2. All of these are subsets. All of them. The only one, if I say this, that means there are 15 of them. I have to leave out this one, the one with all 4. It cannot be equal to the set itself. So I hope that kind of clears that up for you a little bit. We're going to start on something we just had a little bit of last time, intersection and union, but we're going to do more of it this time. So you're going to have to give me just a minute to get this erased. So, small board here that I'm working with. All right, and the first thing we want to talk about, let's talk about things with 2 circles. All right, this stands for the universal set. All the things in our set. If I have 2 circles, they can overlap, or they might not. Okay, now, these have something in common. That little part in the middle belongs to both of them. That's the intersection. It's kind of like the intersection of the road. You know, if you're coming down the road here and somebody's coming this way and you have a wreck here, which street are you on? Well, you're at the intersection of both of them. So the intersection is what they have in common, and this is a symbol for intersection. And here, these don't intersect. So the intersection of these 2 is the empty set. And these are called disjoint. They have no members in common. Now suppose we don't have a picture, but we have this. Let's say set A is a set 1, 2. And set B is a set 2, 4. Well, where the intersection is what they have in common. So the intersection would just be 2. Okay? All right. Now, let's look at these the same set here with 2 sets. This time we're going to talk about the union. And union has the symbol U. That's easy to remember for union. I'm going to put these back. 1, 2, and 2, 4, I think. Okay, and union just means put them all together. Put it all together. So if I want to put these together, I've got 1, 2, and 4. There's no reason for me to list 2 twice. That's the union. Put them all together. Okay? If I want to color that, let's say that's set A and this is B, union will be every bit of these. Okay? That's the union. Now, one of our other symbols, we'll use just one circle. Let's say this is circle A, and we had this. That's called the complement of A, and that means anything but A. So it would be all this stuff out here. Anything but A. So, let's say A is a set 1, 2, 3. So what's anything but A? Well, we got to have what's called the universal set. Where do we stop? What set are we choosing from? Well, let's say we're going from the numbers 1 to 8. So A contains 1, 2, 3. The ones in the universal set that are not here would be 4, 5, 6, 7, and 8. Okay? All right. Now, we're really starting on today's lesson. Again, let me erase just a second. I need a bigger board. All right, suppose that I have a universal set with one circle in it. If there is one set in there, I've got 2 regions. The region outside, all this around here, and the region in the circle. 2 different regions. Okay? This is set A. But if I have 2 circles that overlap and intersect, you know how many circles I have now? I have 4. I'll show you where those 4 regions are. Those 4 regions are 1, that's all around, 2, 3, and 4. 3 is the intersection. Think of this like you were a salesman and you were assigned to zone 1 or area 1. You would cover here. If you were in 2, you would not go into the middle here. You'd have all the homes or businesses in region 2. And then 4 is over here. 3 is in the middle. That's where those overlap. And it's a smaller region, it looks like, but maybe there are a lot of houses or businesses there. Okay. This is 1 set, 2 to the first, 2 regions, 2 sets, or 2 circles, 2 to the second, or 4 regions. You want to guess how many if we have 3 circles? I'm going to draw 3 circles. 3 sets, 2 to the third, should be 8 regions. Alright, I'm going to make these circles overlap. Like this. And that should be 8 different regions. This is 1, 2, 3, 4, 5, 6, 7, and region 8. Alright, and again, that's 2 to the third equals 8. Now, let's work with this one over here just a minute. Let's call this circle A and circle B. And let's say we want to know which regions are in A intersect B. Well, that's pretty simple. It's pretty obvious to look at that one and tell it's region 3. But I want you to get used to doing this. Let's list what all is in circle A. Well, circle A is all of this. So it's 2 and 3. Notice I'm not putting braces because they're not sets. I'm just numbering. And B is 3 and 4. Those are both in circle B. And what's in both of them is 3. And that's what we just said. Okay. Now, the reason I want you to get used to that is, let's say it's this. A prime, or the complement of A. I call it A prime half the time because that's another name for it. What's not in B? Well, which regions, what's not in A? The regions that are not in A are 1 and 4. And the regions in B are 3 and 4. So the intersection is 4. This is the section that is not in A and it is in B. But so that's both, it's not in A, but it is in B. And that's it. And that's the shading. Now you don't want to shade until you've done this because you mess your picture up, you have to draw another one. So I want you to try one, and I want you to do, we're not going to stop the video, but you stop your own video while you try this one. A intersect complement of B. Alright, let me erase this. And you try that one, so stop it long enough for you to do it. Alright, circle A. Back now. 2 and 3 are circle A. What's not in B? Not in B is 1 and 2. So the intersection is 2. This is what you would shade. So that's what's in A that's not in B. Makes sense. Alright, now let's go to 3 regions. This is where it gets a little harder. That's why I want you to get used to doing this. Let's say I want you to, this is circle, I'm going to take these numbers. Well, I can leave them in. This is circle A, this is circle B, and this is circle C. Okay. If I want to do, where does A intersect things not in C? Well, I'm going to list these. What all is in circle A? I see 2, 3, 5, and 6. All of those are in circle A. Again, I'm just writing this for me. It's not a list, it's not a set, it's not called anything. And then the things that are not in circle C. Anything not in circle C is 1, 2, 3, 4. All right, I can see that they both have 2 and they both have 3. So, this would be your shading. Those are the ones that are R in A, but they're not in C. All right, you stop your video long enough. Oh, let me do one more before I get you to try anything. I'm going to do one a little bit different. I haven't done a union. Let's do this kind. A union, parentheses, B complement, intersect C. Alright, now we all know that in math you do parentheses first. But I'm going to go through and I'm just going to number these. Alright, circle A I know is 2, 3, 5, 6. What's not in B, anything that's not in circle B, would be 1, 2, 5, 8. And what is in C, 5, 6, 7, 8. Now, I just said we do parentheses first. And this says to take these regions and find out what they have in common with these. They don't both have a 1, they don't have a 2, they both do have a 5 and an 8. Okay, so that's what's over here. And I'm going to join that together with 2, 3, 5, and 6. I'm just going to take them all. So that gives me regions 2, 3, 5, 6, and 8. Notice I didn't list 5 twice. There's no point. But I took all of them because this stands for the word or pretty much. If they're in this one or this one, take that. Take them both. Take them all. Whereas the intersection is more like an and. Okay, and if I were to shade that, I'd shade 2, 3, 5, 6, and 8. Now, what if those parentheses had been on the first 2 instead of the second 2? Do you think we'd have gotten the same answer? So what I want you to try, you can, I'm going to erase this, I'm going to let you do it all over. Same problem, but we're going to do the union first. And another pen. Alright, so do these first, and then get the intersection with C. Alright, while I erase that, you stop your video, and you work on that problem. And I'm going to redraw. Alright, we're back, or whenever you're back, you can watch this. Alright, A is 2, 3, 5, 6. And I'm going to join that. It says A or not B. Oops, I think I wrote, this is B and this is C. So not B would be 1, 2, 5, and 8. I'm going to do that first. I'm going to join all those together and I get 1, 2, 3. I don't see a 4, but I do see a 5, 6, and 8. I like to keep them in order. It really doesn't matter. And I'm going to find out what's in common with C. C is this circle, so 5, 6, 7, 8. Alright, what do these have in common? They both have a 5, 6, and 8. So our answer is this, and I do not believe that's the same answer we just got before. Alright, now there's a problem in your book that I want you to look at. It is on page 417, example 5. So if you would, stop your video, find that book, find the problem. Let me show you what it looks like. It's this problem, example 5. Alright, find it in your book. And it's talking about a doctor that has 100 patients. And these are all the patients he sees during the day. Some of the people checked off that they had a fever. Some of the people that came to him complained that they had chills. Now, there were some people that had both fever and chills. And then some said, I've got a headache. Some had a headache and a fever. Some had a headache and chills. Some had all three. And then there were some other people that came that didn't have any of those. They must have come for something else other than they had some other symptoms, but not those three. All right, and it gives you all these clues. Now, I'm not going to read them. You can see them. 74 had a fever. 72 had chills, such and such. So I'm going to tell you where to start. Start with all and none. So if I go down to the bottom, I see that 35 people reported that they had all three symptoms. So I'm going to find the place in the circles that has all three. They're in the fever, chills, and the headaches, and they be right there. And I'm going to put the number 35. Also, I see at the bottom that 3 thought they had the flu but didn't have any of the symptoms. So I put all or none. That's the best place to start. Start with all or none when you do these problems. Okay, now I'm going to go to the ones that have 2. 49 said that they had chills and a headache. So where chills and headache overlap, is that little region right there. See that? And that's 49 people. We've already counted for 35, so 14 more makes 49 that should go in there. Now I'll find another one that has 2 symptoms. This is fever and headache, and that will be here and here. And it's 47, so we've already got 35, we'll need 12 more. And then fever and chills, that's here and here. Fever and chills, 55 said they had fever and chills, but they didn't have a headache. We only got 35, so 20 more makes 55. Well, in all, there were 67 people that had a headache. Now, they might have had other things too, but they had a headache. So I add up what I've got in the headache circle. 14, 35, and 12. I believe that's 61, and it's supposed to be a total of 67, so that's 6 more. All right, 72 reported chills. Here's this chills circle. If I add up 20, 35, and 14, let's say that's 55, 65, 69. So we'll need 3 more to make 72. And 74 said fever, and that's this big circle here. So I'll add 20 and 35 and 12. That's 55, 65, 67. We need 7 more. So then you can answer any questions like, how many had a fever only? Be 7. How many had chills only? 3. How many had a headache only? 6. How many had fever and chills but no headache? I think they told us. No, they didn't. Fever and chills but no headache. Here's the fever and chills, but this was headache, so 20. So you can answer questions about them. All right. One more thing. We're going to look at what's called a contingency table. All that is a chart. I'm going to make up one very quickly. Let's say this chart